At the beginning of the semester, we saw the first of 3 American in Motion AGV units that we had the option to work with. As MET majors, we were eager to learn more about the unit itself and how all the components worked on it. Having a physical project to work on was very intriguing, especially for something many of us had never seen before. This meant we needed to learn as much as possible about the AGV unit, as we were given little information from the start since we could not contact the company that initially housed the vehicles. For our problem statement, we were told to use one of the 3 units to create an inventory of mechanical, electrical, and battery charging components, get it operational, moving it with the manual tether controller before and after fabrication, and using the information gained, we were told that we needed to design and build a vehicle that meets the following requirements of carrying at least 300 pounds, can fit in a race trailer, has pure transitional motion in the XY plane, has pure rotational motion about the center of the platform, and uses as much hardware from the original system. This includes motors, sensors, and controllers. While designing concepts, we try to keep in mind that we need to maintain translational motion and the fact the unit needed to rotate about the center platform. Knowing we had little experience with the complex electrical system on this unit, we decided against making an entire new frame and transferring those components. When we confirmed our final concept, we cut the length of the bed to 50 inches, which would satisfy the width limitation of the trailer, and the unmodified width of the unit would meet the length requirement of the trailer. The redesigned frame would move the caster wheels inward, while also reusing the front plate from the original machine, using it as the inboard caster mounting plate. The main idea for this concept would be that it would be used as a glass rack carrier, attaching a glass rack onto the deck, and it would be loaded and sent throughout a factory or warehouse. We began fabrication by first stripping the unit of all unnecessary materials. This included unused batteries, hydraulics, motors, and even cosmetic skirts and panels that covered up the frame. With the scrap removed, we used it to make shims, braces, and spacers. Reusing materials helped keep costs at a minimum. Afterwards, we began the major step of cutting. Cutting the frame involved using a torch, grinder, and saw. Once the machine frame was cut, we cleaned the edges and began welding. Once welding was completed, we began putting the unit back together by remounting the caster wheels, battery tray, panels, and new lift plate. Our fabrication process was basically completed at this point. All that was needed was testing and cosmetically fixing any parts. After everything was said and done, the AGV unit, or as we like to call it, Bertha, was finally completed. Overall, we all had a lot of fun working with each other while trying to reach a common goal. We are very excited to see the response from others and how this will inspire future engineers.